Ever feel like you're drowning in information? You're trying to keep up with these really important topics, especially in tech, but it's just moving so fast.
It can be overwhelming, absolutely.
It's like you need a PhD just to get through the headlines sometimes.
I hear you.
And that's kind of what we try to do here, right? Cut through that noise.
Yeah, on the deep dive, we really try to get to the heart of things, give people the core of what's going on, the stuff that really matters.
Exactly. Without needing that PhD.
Right. Make it accessible and, hopefully keep it fun while we're at it.
Right. And today we're diving into something that's been making waves, not just in tech circles, but everywhere, it seems. Leopold, situational awareness, the decade ahead.
Oh, yeah, that's a good one. It's gotten a lot of people talking.
It really has, and for good reason. We're going to unpack it all today. Think of this as your crash course, or maybe like a back channel briefing on what the top AI minds are thinking, what they see coming down the line.
It's kind of like peering into the future, at least the future, according to some very smart people.
Exactly. And what makes it so compelling is that it's not just, pie in the sky speculation. Aschenbrenner pulls from all these different sources, right?
Mm-hmm.
Published research, obviously, but also his own experience, the general feeling in the AI community, the whispers in the hallways, so to speak.
Yeah, he's tapped into that network of experts. He even gives shout outs to a whole bunch of them, acknowledging where he's getting these insights.
Right, which gives it even more weight, I think.
Mm-hmm.
But there's this central idea in his piece, right, about this small group, mostly in San Francisco, working at these big AI labs who have this, well, he calls it situational awareness.
Yeah, like they're seeing the whole chessboard while most of us are just focused on one or two pieces.
Exactly. And what they see, if you believe Aschenbrenner, is a future that's getting here a lot faster than we realize.
Yeah, the pace of change is mind-blowing. Even to those of us who are paying close attention, it's hard to wrap your head around sometimes.
So let's get right to it. Timelines. Aschenbrenner comes out swinging with this pretty bold prediction: AGI, artificial general intelligence, by 2027. Not just, possible, but plausible. AI at human level, like really soon.
Yeah, it's definitely eye-opening, even if you're kind of expecting it, seeing it laid out like that.
And what's driving this? Like, what's making him think this is actually on the table?
3 big things, mainly. 1, the amount of raw computing power being thrown at this, it's just growing exponentially. 2, the algorithms themselves are getting ridiculously more efficient. And 3, this thing he calls unhobbling, basically figuring out how to unlock the full potential of these AI models, get them to do more than just, chat.
Okay, let's break those down. Compute first. That's the horsepower behind it all, right?
And it's been on this crazy upward curve. Think about it. GPT-2 back in 2019, around 421 FLOPs. Then GPT-3, just a year later, 323 FLOPs. Huge jump.
And then GPT-4 last year, like another order of magnitude up.
At least, yeah, somewhere between 8024 and 4025 FLOPs, depending on who you ask.
So he's seeing this continuing, right? More compute, more power.
Yeah, about half an order of magnitude per year, give or take. By the end of 2027, he thinks we could be looking at training clusters costing tens of billions, maybe even hundreds of billions.
Hundreds of billions for a single cluster. That's like a small country's GDP.
I know, right? It's nuts. But these companies, they're seeing the potential return on that investment, and they're willing to bet big.
Okay, so compute check. You mentioned algorithms getting more efficient too, so it's not just about bigger computers.
No, it's about smarter algorithms. They're finding ways to do more with less. Aschenbrenner talks about this math benchmark, right? There's a bunch of high school math problems, pretty tough ones.
There's like algebra and calculus and all that.
Yeah, stuff that trips up a lot of humans. And just 2 years ago, AI was basically failing at it, like 5% accuracy, something like that.
And
now they're hitting 50% accuracy, and the cost to actually run the model, the inference cost, went down by like a factor of 1,000.
1,000. So it's getting smarter and cheaper at the same time.
Exactly. Aschenbrenner calls these within paradigm improvements. They're like force multipliers on the compute power we already have.
Wow, that's a good analogy. So we've got the power and the efficiency, but then there's this unhobbling thing. What is that exactly?
Okay, so think of it this way. You've got this really powerful AI, right? But it's kind of limited in what it can do. It's like stuck in a box.
Yeah, like a Ferrari with the parking brake on.
Right. And unhobbling is about taking that brake off, letting it loose. Things like reinforcement, learning from human feedback, RLHF. That's where you train the AI based on what humans prefer.
So it's learning from our feedback, getting better at what we want it to do.
Right. And then there's chain of thought prompting, COT, where you make the AI explain its reasoning step by step.
Makes sense. So we're not just telling it what to do, but how to think.
Exactly. And then maybe the most important part of unhobbling is giving these AIs tools.
Tools like
Eh,
hammers and screwdrivers.
Well, not exactly. More like software tools. Imagine an AI that can use a calculator, browse the web, even write and execute code.
That's a huge game changer. Like, it's not just generating text anymore, it's interacting with the whole digital world.
Totally. And another big part of this is context length. That's how much information the AI can process at once.
So, like, it's short-term memory, kind of?
Sort of, yeah. GPT-3 could handle about 2,000 tokens. GPT-4 went up to 32,000. And now we're seeing models like Gemini 1.5 Pro with over 1 million.
1 million? That's insane. So it can, like, read a whole book and remember it all?
Pretty much, yeah. Aschenbrenner uses the example of Gemini learning to translate Calamang, which is this language barely anyone speaks, just by being fed the right materials.
Just like that, no special programming or anything?
Nope, it just learned from the context, like a human would.
Wow. So longer context means a smaller model can do more, right? It's like a form of efficiency in itself.
Right, it's like giving a smaller team a bigger toolbox, they can get more done.
Makes sense. You also mentioned agent scaffolding before. What's that all about?
So it's basically about giving the AI a framework to work within, like a plan or a set of steps to follow.
So we're not just building smarter AIs, we're teaching them how to work smarter.
Exactly, and it's paying off. Studies are showing these methods can give you 5 to 30 times better performance on benchmarks, just from improving the training process and giving the AI the right tools and scaffolding.
Impressive. But Aschenbrenner doesn't think we've unhobbled everything just yet, right? There's still some limitations.
Yeah, he points out a few big ones. First, this lack of thinking before speaking. Right now, AIs are pretty reactive. They don't really plan things out like we do.
And we humans, we spend a lot of time thinking, strategizing before we act.
Right, and AIs aren't there yet. They're also mostly limited to short back and forth conversations. They can't really engage in these long-term projects like we can.
And they're not really personalized, are they? Like, they're kind of one size fits all.
Yeah, that's another big one. But he's optimistic that we can overcome these limitations.
So what are the potential breakthroughs he sees on the horizon?
Well, first, solving that onboarding problem with these super long context windows. Imagine giving an AI all the information about a company, all their documents, emails, everything.
So it's like instantly bring them up to speed, like a super fast orientation.
Exactly. And then there's this thing called test time compute overhang, which is a bit of a mouthful.
Yeah, what's that all about?
So right now, AIs have a limited amount of compute they can use when actually solving a problem. He compares it to the amount of time a human would spend thinking about it.
Okay, so a few hundred tokens is like a few minutes of thinking, but millions of tokens could be months of work.
Right. And if we can give AIs more compute at test time, let them think longer, they could get way smarter, even without improving the underlying intelligence per token.
Interesting. So it's not just about how smart the AI is, but how much time it has to think.
Exactly. And he points to research in other areas, like game-playing AIs. They've shown that giving them more time to compute during the game can compensate for less training time.
So smaller AIs could potentially perform like bigger ones if they have more time to think.
Yeah, and he even speculates that a 4 order of magnitude increase in test time compute could be like the jump from GPT-3 to GPT-4.
Wow, that's huge. And the third big breakthrough is letting AIs interact with computers more like we do, right?
Yeah, like using Zoom, doing research online, sending emails, using all kinds of software.
So basically turning them into superpowered digital assistants.
That's the idea. They could manage projects, collaborate with us, basically become these incredibly capable colleagues.
Okay, so if we put all this together, the compute, the algorithms, the unhobbling, Aschenbrenner thinks we're heading for another massive leap in AI capability by 2027, maybe even bigger than what we saw with GPT-4.
And he's basing this on actual trends, not just, wishful thinking. He does acknowledge some potential roadblocks, like the data wall.
The what now?
The data wall. It's this idea that we might run out of internet data to train these ever-growing AIs.
Right, because they need massive amounts of data to learn.
Exactly. And at some point, you're just feeding them the same stuff over and over again, and it stops being helpful.
So what's the solution?
Aschenbrenner thinks we need to find ways for AIs to generate their own training data, kind of like how AlphaGo taught itself to play Go.
So it's like bootstrapping themselves, becoming self-sufficient learners.
Right, and if we can crack that, it could unlock even faster progress because they wouldn't be limited by the data we can give them.
Okay, so AGI by 2027, plausible, maybe even likely. But then what? does it just stop there?
Oh, no, it definitely doesn't stop there. Aschenbrenner takes it a step further. He talks about the transition from AGI to superintelligence, and that's where things get really wild.
Superintelligence, that's AI that's not just as smart as us, but way, way smarter.
Wow, like orders of magnitude smarter across the board.
And he thinks this could happen pretty soon after AGI.
That's his argument, yeah. He talks about this idea of the intelligence explosion, where millions of AGIs are used to automate AI research itself.
Wait, so AI is designing and building even smarter AIs?
Exactly, and it could happen insanely fast. He thinks they could compress decades, maybe even centuries, of progress into a single year.
That's, like, unimaginable. It's hard to even wrap your head around the implications of that.
I know, it's mind-blowing. And he addresses that concern about physical research, like robotics and biology, things that need labs and experiments.
Right, because AIs can't do that stuff yet. They're mostly digital.
But his point is that the biggest bottleneck right now is algorithmic breakthroughs, and that's something AIs can do in simulation.
So once they can design better AIs, everything else could accelerate too, even if it's not as explosive.
Right, because they'd have these super smart AI tools to help them.
Makes sense. And he actually tries to quantify this, right? Like, how much research could these AIs do?
Yeah, he estimates that by 2027, we could have the hardware to run millions of these automated AI researchers, potentially equivalent to over 100 million human researchers.
100 million. That's more researchers than there are people in some countries.
I know, it's crazy. And he even suggests they could work 10 to 100 times faster than us because they don't need sleep or breaks or anything.
It's like this massive intellectual army dedicated to pushing AI forward.
And he addresses some of the common objections, like the idea that ideas are getting harder to find, that we're running out of low-hanging fruit.
Yeah, that makes sense. Science is getting more complex, more specialized.
But his counter is that the sheer scale of this research effort would just blow that out of the water. It's a million-fold increase. There's bound to be tons of new breakthroughs.
And what about diminishing returns? That each improvement gets progressively harder to achieve.
He acknowledges that, but he thinks the initial boost would be so huge that it would overcome that for a while. Like, it would take a long time for diminishing returns to really kick in.
Okay, so it's not just about the quantity of research, but also the quality, right? These AIs could do things human researchers can't.
Absolutely. They could focus for centuries, avoid mistakes, optimize their experiments perfectly, explore tons of ideas in parallel. He talks about training 100,000 GPT-4 level models in a year just to try different ideas. That would be like a small experiment for them.
That's mind-boggling. And the outcome of all this wouldn't just be slightly smarter AI, right? He thinks superintelligence would be qualitatively different.
Yeah, he uses the example of AlphaGo's move 37 against Lee Sedol, this brilliant move that no human expert saw coming.
I remember that. It was like AlphaGo was thinking on a completely different level.
Right. And he thinks superintelligence would be like that, but across all domains. He even compares it to how hard it is for high school students to understand quantum mechanics. The concepts are just too advanced.
It's like we'd be dealing with something fundamentally beyond our comprehension.
Exactly. And he uses the example of video game speedruns, how players find these incredibly efficient, often seemingly illogical ways to beat the game.
I've seen some of those. It's like they're exploiting glitches in the code, bending the game to their will.
Right. And he thinks superintelligence could do that with reality, optimize things in ways we can't even imagine.
Okay, so that's the potential, but obviously there are huge challenges too, right?
Yeah.
That's the third part of Aschenbrenner's analysis.
Yeah. He lays out 4 big ones, and they're all interconnected.
First one is racing to the trillion-dollar cluster, which sounds pretty ominous.
It is. Basically, he's describing this insane acceleration in investment in AI. He thinks total global investment could hit $1 trillion a year by 2027.
$1 trillion? That's more than some countries spend on their entire military.
I know, it's wild, but the potential returns are just that big. And it's going to lead to these massive training clusters, individual ones costing hundreds of billions.
They mentioned some examples, right? Like Meta buying up all these GPUs, Amazon building these huge data centers.
Yeah, and rumors of even bigger projects, maybe even $1 trillion cluster by 2030.
And the energy demands for that would be astronomical, right?
Yeah.
He says like 100 gigawatts. That's more than 20% of U.S. electricity production.
Yeah, power is going to be a huge bottleneck. Building new power plants takes time, especially the clean ones.
So what's the solution?
Aschenbrenner thinks natural gas might be the only option in the short term, at least in the U.S. It can scale fast, and there's a lot of it.
But it's not exactly clean, is it?
No, it's definitely not ideal, but it might be the only way to get the power we need quickly.
And what about the chips themselves? Are we making enough of those?
He says current production could almost meet the demand for the near-term clusters, and TSMC, the main chip maker, could theoretically build enough for a $1 trillion cluster if they went all in.
But they're bottlenecks, right?
Yeah, advanced packaging and memory are the big ones, but TSMC is working on it.
Still, it sounds like a massive logistical challenge.
It definitely is, and Aschenbrenner makes the point that it matters where these clusters and fabs are built.
Right, because it's not just about technology, it's about geopolitics.
Exactly. He wants the U.S. to be the leader in this, not China.
Okay, second challenge is lock down the labs. Security for AGI, which sounds pretty self-explanatory.
Basically, Aschenbrenner is saying that AI labs aren't taking security seriously enough, and that's a huge problem.
Because the stakes are so high now, right? AGI is like the ultimate weapon.
Right. He compares it to nuclear secrets.
Yeah.
And he says stealing AI models is as easy as copying a file.
And if a country like China gets AGI first, it's game over.
Pretty much, yeah. They'd have a massive advantage. They could automate their research, maybe even skip safety measures to get to superintelligence first.
And there's nothing stopping them from stealing our research.
Not really, no. We have export controls on chips, but not on algorithms.
That's scary. And it's not just theoretical, right? Companies like Microsoft get hacked by state actors all the time.
All the time. Aschenbrenner says we need government-level security for this stuff. Private companies just can't handle it.
So it's like the Manhattan Project all over again. Top secret, need-to-know basis.
Exactly. But he says there's this weird disconnect. AI labs know how important this is, but they're not acting like it.
Okay, third challenge is super alignment, which sounds like a superhero team.
But it's actually about how we control superintelligent AI, how we make sure it's aligned with our values.
Because if it's not, we're in big trouble, right?
Huge trouble. And Aschenbrenner says this is an unsolved problem. There's no guarantee we can do it.
And current methods like RLHF won't work for superintelligence, right?
No, because RLHF relies on humans understanding what the AI is doing. And with superintelligence, we just won't.
It's like we'll be too dumb to even know if it's doing something dangerous.
Right. He gives the example of an AI writing code in a language we don't understand. It could be hiding all sorts of bad stuff in there.
And it's not enough to just align human-level AI because the intelligence explosion could happen so fast.
Yeah, by the time we get there, the first superintelligences might already be way ahead of us.
So we need a way to align something that's already smarter than us.
Yeah, it's a huge challenge. Aschenbrenner talks about different approaches, like trying to reverse engineer how AIs think or getting them to reveal their knowledge.
But those are all long shots, right?
Yeah, no guarantees. He thinks chain of thought interpretability might be helpful, where AIs explain their reasoning in human language.
So we can at least try to understand what they're thinking.
Right, but even that might not be enough. And he stresses that we need to be doing this research now, not waiting until it's too late.
And he wants AI labs to dedicate a lot of resources to this, right?
Yeah, a big chunk of their compute power should be going towards alignment research.
Because if we get this wrong, there's no going back.
Exactly. And he warns against assuming that just because current AI seems safe, superintelligent ones will be too.
They'll be playing by different rules, basically.
Right. And he uses this analogy of running a war, you have to be prepared for anything.
No room for complacency.
None at all. And the last challenge is the free world must prevail, which is pretty heavy.
Yeah, this is where it gets really geopolitical.
Right. Aschenbrenner's point is that superintelligence is the ultimate prize. Whoever gets it first will dominate.
So it's like the new arms race, but with AI.
Exactly. And he says the free world has to win this race, not China or any other authoritarian regime.
Because the stakes are too high.
The stakes are existential. He talks about how a technological lead can translate to military power, like in the Gulf War.
Right. The U.S. had superior technology, and they basically steamrolled Iraq.
And he thinks a lead in superintelligence would be even more decisive. It would be like condensing a century of progress into a few years.
So we're talking about AI-powered cyber warfare, robot armies, stuff like that.
Yeah, and he outlines how China could catch up. They're building out their compute infrastructure. They're stealing our algorithms.
And they're not afraid to use any means necessary to achieve their goals.
Nope. And he specifically warns about the danger of a dictator having access to superintelligence.
That's a terrifying thought. Basically unlimited power.
And he points to the CCP's track record, their human rights abuses, their ambitions for global dominance.
It's not a risk we can afford to take.
Not at all. Aschenbrenner says we need a significant lead, not just to win the race, but to buy ourselves time to figure out alignment.
So it's like a buffer, a margin of safety.
Right. And he even suggests offering China a deal once we're ahead, a kind of non-proliferation treaty for superintelligence.
But can we trust them to keep their word?
That's the big question. But he thinks it's worth trying because the alternative is too risky.
Okay, so those are the challenges, but what's the solution?
Yeah.
Aschenbrenner lays out his vision for the project.
This is his idea for a massive government-led effort to develop AGI and superintelligence safely and responsibly.
So like the Manhattan Project, but for AI.
Exactly. He says private companies are great at innovation, but they can't handle something of this scale and importance.
It needs to be a national effort with all the resources of the government behind it.
Right. He compares it to the COVID pandemic, how the government eventually stepped in with a huge response.
And he thinks the same thing will happen with AI once the reality of the situation becomes clear.
Yeah, once people see what's coming, there will be a demand for action, a kind of AGI Manhattan Project.
And what would this project look like?
He thinks it would probably be a collaboration between the government, cloud providers, and AI labs, kind of like how the DoD works with defense contractors.
So not full nationalization, but a close partnership.
Right. And he thinks the core research teams would be moved to secure locations, and there would be a massive build out of infrastructure.
The trillion-dollar clusters we talked about earlier.
Yeah, exactly. He says this is the only way to do it, given the stakes.
And national security would be the top priority, right?
Absolutely. Aschenbrenner talks about reshaping the military, deploying superintelligence for defense first.
Because we can't let China get ahead of us in this.
And he stresses the need for a clear chain of command, government control of this technology.
He compares it to nuclear weapons. You can't have private companies controlling that.
Right. And he says civilian applications will come later, after the national security issues are sorted out.
Which makes sense. It's like how the internet started as a military project.
Exactly. And he keeps hammering on the need for security, tight controls on who has access to this stuff.
Because the risks of leaks are just too high.
And he describes the intelligence explosion as this chaotic, rapidly evolving situation, like a fog of war.
So the government needs to be agile, able to adapt quickly.
And competent, obviously. He says the key questions are when this project starts and how well it's run.
Because it's not a matter of if, but when.
Right. And his final prediction is that the intelligence explosion will be underway by 2028 or 2029, and we'll have superintelligence by 2030.
So we're talking about a very near future, not some distant sci-fi scenario.
And it's going to be a wild ride, that's for sure.
So there you have it, our deep dive into Leopold Aschenbrenner's situational awareness. A lot to think about, a lot to process.
It can be hard to believe, even for people in the field, it's moving so fast.
But these are the people who are building this future. They're the ones with their fingers on the pulse.
And whether the timelines are exactly right or not, the general trends are clear and the implications are huge.
So what do we do with this information?
That's the big question, isn't it? This is a future we're all going to be living in, so it's worth thinking about, asking questions.
What does it mean for our jobs, our society, our security?
What role do we want to play in shaping this future?
And what are the things we should be doing now to prepare for it?
Those are the questions we all need to be asking ourselves.
Thanks for joining us on this deep dive. It's been a wild one.
Yeah, this is definitely one for the history books, and we're living it in real time.
Until next time, stay curious, stay informed, and buckle up, because things are about to get really interesting.
You can say that again.